Okay, so next type of logical instruction we have under this group is CMPR. So CMPR is the instruction, means if we want to compare the contents of the accumulator with the contents of the register pair, then we can use this instruction, that is CMP. So basically this instruction we can use for the comparison. Okay. So so this instruction means compare the contents of accumulator with the contents of register. Okay, so this is the meaning of instruction CMPR. Now we can see the format of the instruction. So in this case, the format is the contents of the accumulator will be compared with the contents of the register pair by the method of subtraction. So the operation is performed by subtracting the register contents from the accumulator contents, but after the execution, the subtraction result will not stored in the accumulator again. Only we are comparing the contents by using the subtraction method, but after subtraction, in case of SUB or in case of the arithmetic subtraction instruction, the result will be stored after the execution in the accumulator. But in case of compare instruction, after the subtraction, the result won't store in the accumulator. Okay, so the accumulator contents remains same, that is after the execution as well as that is before the execution. So after format, now we have next is number of bytes. So this instruction will occupy 1 byte of memory, because again in this instruction no data or address is specified. Next we have is the addressing mode. So you can see in this instruction the register name is given. So the value of one register, that means the value of one general purpose register, will be compared with the value of another general purpose register. So both the source as well as the destination is general purpose register. So that means the addressing mode is register addressing mode. Okay. Next we have is the flags affected. So after the execution of this instruction, all flags will be affected. Okay, so this is compare instruction. Now in this case, while we are comparing the contents of the accumulator with the contents of the register pair, then we have three types of comparison. First, either the value of accumulator will be greater than the value of register, either the value of accumulator will be equal to the value of register, or whether the value of accumulator will be less than that of the value of register. Okay, so when the value of accumulator is greater than the value of register, that means the result is positive. Suppose in accumulator we have 20 and in register we have 10. So that means when we can subtract 20 minus 10, the result is positive of 10. So when the result is positive, that means carry flag is always equal to 0. So that we did in the subtraction part in arithmetic group. Okay. Next we have A is equal to R. So when both the values are equal, that means the result is 0. So when the result is 0, that means 0 flag is equal to 1. Okay. Next we have when the value of accumulator is smaller than the value of register. So when we have 10 in the accumulator and 20 in the register, so the result is minus of 10. So when we have the negative result in case of subtraction, then always the carry flag is equal to 1. So in this case, carry flag is equal to 1. Okay, and in this case also 0 flag is equal to 0 because result is non-zero, and same in this case. Okay, so these are the three conditions, and according to these three conditions, these values are fixed. Okay, now we can see the example. So for example, we have an instruction that is CMPB, and in the accumulator we have contents 20H, and in the B register we have contents 10H. So after the execution of this instruction, what will happen? After the execution, the contents of A remains same, as well as the contents in the B register also remains same. Only the flag register values will be changed. Okay. So after the execution, see now which condition is satisfied? This condition is satisfied where the contents of accumulator are greater than the contents of register. So according to this instruction, after execution, carry flag is equal to 0 and 0 flag is also equal to 0. Okay. So other values you can see after subtracting 20 by 10, what will be the value of parity, what will be the value of sign and auxiliary carry. Okay. That you can see. Now, this is the compare register. Now, next we have an instruction that is CMPM. So, this instruction means compare the contents of the accumulator with the contents of the memory location, that is pointed by HL pair. That is pointed by HL pair. So that is the meaning of instruction CMPM. Okay. So again, the format of this instruction is here. Other than R, we can write HL. So the contents of the memory location that is pointed by the HL pair will be compared with the contents of the accumulator by using the subtraction method. So this instruction will again occupy 1 byte of memory because only opcode is written in the instruction. Addressing mode is register indirect addressing mode because directly we are not comparing the contents with the accumulator. We are comparing the contents of the memory location, and that memory location will be pointed by this HL pair. So the process is indirect. That's why the addressing mode is register indirect addressing mode. Again, this is the compare instruction. So all flags will be affected according to the contents of the accumulator. So here we have the comparisons are same, but other than R, here we are comparing the contents of the HL pair with the contents of the accumulator. So here we have the conditions like this. So again, if the contents of A are greater than the contents of the memory location that is pointed by this HL pair, then CY is equal to 0 and Z is equal to 0. And if the contents are same, then Z is equal to 1. If the accumulator contents are smaller than the contents of the memory location, then CY is equal to 1. Okay, now we can see the example. So suppose we have an instruction that is CMPM and M means HL pair is having data D00AH, and at this address we have value that is 94H, and in the accumulator we have value 97. In the accumulator we have value 22H, suppose. Okay, so in this case this condition is satisfied where the contents of accumulator are smaller than the contents of the memory location. At that memory location will be pointed by this HL pair. So here in this case we are comparing the values of accumulator and of this memory location. So according to this value, after execution, what will be the value of carry flag? So after the execution, the carry flag is having value 1, because 22, when we can subtract 94 from the 22, then the result is negative. So when the result is negative, then the carry flag is equal to 1. So this is about CMPM. Okay, now we can see the next compare instruction, that is CPI data. CPI data means compare the contents of the accumulator with the contents that are written in the contents that are in the instruction. So whatever contents we have present in the instruction, that will be directly compared with the contents of the accumulator. So here instead of HL, the data is directly given in the instruction. So that data will be compared with the contents of the accumulator by using the subtraction method. So in this case, this instruction will occupy 2 bytes of memory, 1 byte for this data and 1 byte for this opcode, that is CPI. Addressing mode. So the addressing mode of this instruction is immediate addressing mode because I is given in the instruction as well as the data is directly given in the instruction. So this instruction is a immediate type of instruction. Next, flags affected. So again, all the flags will be affected after the execution of this instruction. Now we can see the comparison. So again, other than H and L, we are comparing it with the data only. So whether the value of A is greater than data, or it is equal to data, or it is less than data. So when the value of accumulator is greater than the data, then Cy and Z is equal to 0. When these are equal, then Z is equal to 1. And when the value of accumulator is smaller than data, then Cy is equal to 1. So now we can see the example. So suppose we have an instruction that is CPI05H, and in the accumulator we have contents 05H. So this 05 will be compared with the data that is given in the instruction. So which condition is satisfied? This condition is satisfied. So when this condition is satisfied, that means after the execution, 0 flag is having value 1, because when the result is 0 in the accumulator, or when the result is 0 after the comparison, then 0 flag is always equal to 1. Okay, so this is about the instruction CPI data. So we have 3 different types of compare instructions in 8085. Either we can compare the data directly, either we can compare the data that is present in the register, or we can compare the data that is present in any memory location, and that memory location will be pointed by the HL pair. Okay, so this is about the compare instructions. Now we can see next instruction, that is complement instruction, CMA. So CMA means complement the contents of accumulator. So this is the meaning of instruction CMA. Okay, so complement the contents of accumulator. Now, complement means if we have one value, then it will be complemented with 0. If it is 0, then it becomes or it get complemented with 1. Okay, so the format of this instruction is, after complementing the contents of the accumulator, the new result will be stored in the accumulator. So for complementing, we can use the bar symbol. So this instruction will occupy only 1 byte of memory, because again in this instruction no explicitly data or address is defined. Addressing mode. So this instruction is having addressing mode, that is implicit or implied addressing mode. Why? Because here in this instruction you can see the contents which microprocessor is going to complement are present in the opcode only. So here we have a accumulator, that is the part of the instruction. No, here in this instruction you can see no register name, no address, or no data is explicitly defined. Okay, so we have only opcode. So that means the addressing mode of this type of instruction is implicit addressing mode. Now we can see the flags affected. So after the execution of CMA, no flags will be affected. Okay, so the value of flag remains unchanged after the execution of CMA instruction. We can see the example. Okay, so we can see the example. So suppose before execution, we have an instruction CMA, and before execution in the accumulator we have contents ABH. So ABH means 1010 011. Okay, now after the execution, what will happen? After the execution, one value will be replaced with 0 and 0 will be replaced with 1. So this 1 is 0, this 0 is 1, 0, 1, 0, 1, 0, 0. So after the execution, this value becomes 5, 4H. So after complementing ABH, the value in the accumulator will be 54H. So after the execution, now accumulator will get new value, that is 54H. So this instruction means after complementing, again the contents will be stored in the accumulator. Okay, so this is the meaning of CMA. Is it clear? Now, after this, we can see next instruction, that is CMC. CMC means complement the carry flag. Complement the carry flag. That means if in the carry flag one value is present, that is complemented with 0, and if in the carry flag 0 is present, that means that is complemented by 1. So here we have CY. So the value of carry flag will be complemented, and afterwards it will again stored in the carry flag. So again, this instruction is 1 byte instruction. The addressing mode is implicit addressing mode, because again in the opcode we have a carry flag which microprocessor is going to complement. Okay, so the addressing mode is implicit addressing mode. Flags affected. So according to this instruction, only carry flag will be affected. Okay, so only carry flag will be affected after the execution, because microprocessor is performing the operation with the carry flag. So if microprocessor is performing the operation with the carry flag, that means only carry flag will be affected after the execution of CMC. So suppose before execution we have an instruction CMC. We have an instruction this, that is CMC. And in the carry flag we have contents, that is in the carry flag we have 1 before the execution. So after the execution of instruction CMC, carry flag is having value 0. Okay, or suppose before execution carry flag is having value 0. So after execution the carry flag is having value 1. So that means complementing the carry value. If it is 1, then after execution it is 0. If it is 0, then after execution it becomes 1. Okay, so this is the simple meaning of CMC. Now, after this, next instruction that is related to the carry flag is STC. STC means set the carry flag. Set the carry flag. Set means to put 1 into the carry flag, and reset means 0. Set means 1. So this instruction means we can store 1 into the carry flag. This instruction is again of 1 byte, because no address data is given in the instruction. Addressing mode is again implicit addressing mode, because again we have a opcode, this opcode, and inside this instruction we have a carry flag that we have to update with value 1. Flags affected. So again this instruction will deal with only carry flag. So only carry flag will be affected after the execution of this instruction. So before suppose we have an instruction that is STC, and before execution carry flag is having value 0. Okay, so this instruction will do what? This instruction will set the carry flag. So if before execution carry flag is having value 0, so after execution it becomes 1. And suppose if before execution carry flag is having value 1, then after execution it remains same, that is equal to 1. So after the execution of this instruction, always the value of the carry flag is 1. That is always the value of carry flag is set after the execution of this instruction. Okay, so this is the meaning of STC. Now we are left with 4 more instructions, and those instructions are related to the rotate operations. So we have 4 rotate instructions in 8085, that is RAL, RAR, RLC, or RRC. So total we have 4 instructions in 8085. Okay. Okay, so we have 4 rotate instructions: RAL, RAR, RLC, and RRC. So these 4 instructions are very, very important instruction according to your board point of view also. Okay, so we can start with the first instruction, that is RLC. So RLC means rotate accumulator left. This instruction means rotate the contents of accumulator to left. Okay, so this is the meaning of RLC. So this instruction will rotate the contents of the accumulator to the left side by 1 bit. Okay, so by 1 bit, this instruction will rotate the contents on the left hand side. So the format of this instruction is that we can discuss later after I am drawing the diagram. Next, we have number of bytes. So this instruction will occupy 1 byte of memory, because again in this instruction explicitly no data or address is given. Addressing mode. So the addressing mode of this instruction is also implicit or implied addressing mode, because in this instruction we can rotate the contents of the accumulator. So that is inside the opcode only, that is not explicitly specified in this instruction. If anything is explicitly specified in the instruction and if we are performing any operation with that, then the addressing mode is something other than the implied. Okay, flags affected. So again, according to this instruction, only carry flag will be affected. Only carry flag will be affected. Other flags won't get affected after the execution of all these 4 instructions. We can see this instruction. So before that, we can draw the diagram. So before execution and after execution. So we have a accumulator, and the accumulator is of 8-bit. Okay, so this we have a accumulator, and this accumulator is of 8-bit. That starts from A0, then we have A1, then we have A2, A3, A4, A5, A6, and we have A7. And here we have a carry flag that will be represented by CY. Okay, so this is accumulator which is having 8 bits that starts representing from A0 to A7. So this is accumulator. Okay, now according to this instruction, whatever contents we have or whatever bit we have in A0, that will be moved into A1. The bit of A1 will be moved into A2. So every bit will be shift 1 position on the left side, and the contents of this A7 will move into the carry flag, as well as the contents of A7 will be moved into A0 also. So after the execution, this will happen. Okay. So according to this, now we can see the format. So here, the contents of A0 will move into A1, and the contents of A1 will be moved into A2. So in case of format, we can write a generalized formula. So that means whatever contents we have in AN, that will be moved into AN plus 1. Whatever contents we have in A7, that will be moved into A0, as well as the contents of A7 will be moved into carry flag. So the contents of A7 will be moved into carry flag, as well as the contents of A7 will be moved into A0, and the contents of A0 goes into A1, A1 goes into A2, like this. Okay, so this is the format of instruction RLC. Now, we can see the example of RLC. So, before execution, suppose we have in the accumulator 1FH. So, these are the contents in the accumulator before the execution, and in the carry flag, we have value 0 before the execution. So, we can see the result after the execution. So, for that, again, I am drawing this diagram. This is A7, A6, A5, A4, 3, A2, A1, and A0. Okay. So you can see here in the carry flag we have 0, 1F in the accumulator. So this is 0, 0, 0, 1, F 1. F is 1, 1, 1, and 1. So this is before the execution. Now after the execution, we can see the contents of A0 will moved into A1. So this value A0 will move into A1. The value of A1 moved into A2. The value of A2 will be moved into A3. The value of A3 will be moved into A4. The value of A4 will be moved into A5. The value of A5 will be moved into A6. The value of A6 will be moved into A7, and the value of A7 goes into the carry flag, as well as this value goes into the accumulator, A0 also. Okay, so this is the process after the execution. So now you can see the contents. This is 0011 is 3 and 1110 is E. So after the execution, accumulator is having contents 3EH and the carry flag is having value 0. So this is the value after the execution of instruction RLC, when we have in the accumulator 1FH and in the carry flag we have value 0. Okay, so this is the meaning of this instruction. Now we can see the next instruction, that is RAL. RAL means rotate the contents of the accumulator to left with carry. So in this instruction, while we are rotating the contents of the accumulator, at the same time microprocessor will rotate the carry flag also. So carry flag will be, the value of carry flag will be rotated also with the contents of the accumulator. So in this case, carry flag is also included. So according to this instruction, initially we can see number of bytes, so that remains same. Addressing mode remains same. Flag affected remains same. Now before execution, we can see the diagram. So here we can take different example. So before that, you can see the diagram. So here, in this case, the contents of A7 will goes into the carry flag. As I told you, while we are rotating the contents, carry flag value will also be included. Okay, so the value of A7 goes into CY, and this CY value will goes into A0. So this is the rotation is like this, where we can include the carry flag also. So according to this instruction, this format is same. Now the value of A7 goes into CY, while the value of CY goes into A0. Okay, so this is the only change in this instruction. So here the carry flag is also included by the microprocessor during the rotate operation. Okay, now we can see the example of RAL. So suppose we have example where accumulator is having contents 1EH and in the carry flag we have value 1. Okay, so this is the instruction where A is equal to 1EH and carry flag is having value 1. So this is before execution. Now we can see carry flag is having value 1. A is having value 1E. So 1E means 0001. E means 1110. Okay. So after execution, now we can see the content. So before that, I will remove these values. Now you can see this 0 goes here, this 1 goes here, this 1 goes here, 1 into A4, this A4 value goes into A5, A5 value goes into A6, A6 value goes into A7, and the value of A7 goes into carry flag, while the value of carry flag goes into A0. So the value of carry flag was before execution 1, and after execution this value goes into A0. Okay, so now you can see the contents of the accumulator after the execution. What will be the contents? So this diagram, so what will be the contents after the execution? So here, if you can see, our example is correct or not. This 0 goes here, this 1 goes here, 1, 1, 1, this 0, and this 0 goes here, and this 1 goes here. Okay. So according to this, in the after the execution, in carry flag we have value 0, and in the accumulator after the execution, what will be the value? This value is 3, and 1101 is 3D H. Okay. So after the execution, accumulator is having value 3D H. So this is the meaning of this instruction, that is RAL. Okay. So is it clear? Okay. So this is about RAL. Okay. Now we can see the next instruction, that is RRC. RRC means rotate the contents of the accumulator to right. Okay, rotate the contents of the accumulator to right. So here in this instruction, carry flag is not included while we are rotating the contents. So initially, format we can see later. Now we have number of bytes. So this instruction will occupy 1 byte of memory. The addressing mode remains same, that is implied. Flags affected also, only carry flag will be affected. So before execution, now we can see the diagram first. So in this case, we are rotating the contents on the right hand side. So arrows is towards the right side. So here the arrows towards the right side. Okay. Now, so the arrow is towards the right side. Now you can see here, according to this instruction, the contents of A7 will goes into A6, the contents of A6 will goes into A5. So likewise, every content will be shifted on the right side by 1 bit, and the contents of this A0 will goes into A7. Okay, and similarly the contents of A0 will also goes into carry flag. So the contents of A0 will goes into carry flag, as well as those contents will goes into A7, and the contents of this will goes into right side by 1 bit. So we can see A7 means the value of AN plus 1 will goes into AN. The value of A0 will goes into A7, as well as the value of A0 will goes into carry flag according to this diagram. Okay, so this is our RC instruction. Now we can see the value, and using the example we can see how the values remains changed. Okay. So for RRC instruction, suppose we have data in the accumulator, that is 1CH. Okay, and carry flag is having value 1. So carry flag is having value 1, and in the accumulator we have 1C. So 1C means 0, 0, 0, 1. C means 12. Okay, so 8, 9, 10, 11, 12, 13, 0 and 0. Okay, so 1, 1, 0, 0. So according to this instruction, we can see the contents of carry flag and the accumulator. Okay. So see here, the contents of A7 goes into A6. So the contents of this A7 goes into A6, so that is 0. A6 goes into A5, again 0. A5 goes into A4, 0. A4 goes into A3, that is 1. A3 contents goes into A2, 1. A2 content goes into A1, that is again 1. The contents of A1 goes into A0, that is 0. Okay, and the contents of A0 will be updated in the carry flag, as well as that value will be updated in A7. Okay, so that is the instruction. So you can see in this instruction, after the execution, carry flag is having value 0, while in the accumulator we have value 0, and this 1110 is 0EH. So after the execution of this instruction, accumulator is having contents 0EH, and the carry flag is having value 0. Okay, so this is the meaning of instruction RRC. Now we are left with one more instruction, that is RAR. So RAR means rotate the contents of the accumulator to right side with carry. Okay, so in this case, we are also including the carry flag. So that means the value of A0 will goes into the carry flag, while the value of carry flag will goes into A7. Okay, so this is the meaning of this instruction. So there is a little bit change in the format. First is same. Now the value of A0 goes into carry flag, and the value of carry flag will goes into A7. Okay, so this is the circular path on the right side, where one bit will be shifted on the right hand side, including the carry. And in case of RRC, carry is not included while we are rotating the contents, while in case of RAR, carry is also including while rotating the contents. So again, number of bytes, addressing mode and flags affected remains same. Now we can see the example. So according to this instruction, suppose in the accumulator we have contents 0EH. Okay, so in accumulator we have contents 0EH, and in the carry flag we have value 1. So in carry flag we have value 1. Here we have value 0E. So 0, 0, 0, 0, 1, 1, 1, 0. So these are the contents in the accumulator. So after the execution, now we can see the result. Okay, now see. Here the value of A7 goes into A6. So A6 is 0. A6 goes into A5. A5 goes into A4. A4 goes into A3. A3 goes into A2. A2 goes into A1. And A1 goes into A0. Okay. And the value of A0 goes into the carry flag, while the value of carry flag goes into A7. Okay, so this is the meaning of this instruction. So after execution, you can see the carry flag is having value 0, while in the accumulator we have value 8, and this value we have 7. So after the execution, the accumulator is having value 87H. So this is about the rotate instructions in 8085. Okay, and these instructions are very, very important instructions. This instruction will also come for 1 mark. In 1 mark, the examiner will ask which flag value will be affected, or which flag will be affected after the execution of this instruction, or how many bytes of instruction it is. Okay, or they can ask you about the addressing mode of the instruction. Okay, now we can see the example that is related to the logical operation. For example, we have a memory location 2501H, and at this memory location we have contents, and those contents we have to complement, and after complementing the contents we have to store the result at memory location 2502H. So how we can write the program? So we have contents at this memory location, and we can apply the complement operation with accumulator only. So that means initially we have to load the contents in the accumulator. Okay, so for that we have an instruction that is LDA. After LDA we can write 2501H. So this means load the contents of the accumulator, with the contents of this memory location. So whatever contents we have at this memory location will be loaded into accumulator. Now we can write CMA. So this instruction will complement the contents of accumulator. Then after complementing the contents, now we can store the contents of accumulator at memory location 2502H. And after this, we can close the program either by writing halt, or we can write RST0. Okay, so we can write anything to close the program. Okay. Next program we have, suppose we have the data at this memory location, and we have to find the 2's complement of the data, and the result again we have to store at this location. So that means if we want to find the 2's complement, then we have to add the 1's complement with 1. Okay, so 1's complement plus 1 is equivalent to 2's complement. So the instruction is same. So initially we can put the value of this memory location into accumulator. Then we can complement the contents of accumulator. Then we can write instruction ADI01H. So this instruction means whatever contents we have in the accumulator, that will be immediately added with the contents that are given in the instruction. So here we have 0, 1, and the result is again stored in the accumulator. Okay, so that means using these two instructions we can find the 2's complement. So after this we can write STA2502H and then we can write halt. Okay, so this is how we can find the 2's complement of a number. So these are the different logical instructions in 8085. If you have any doubt, then you can ask. Otherwise, we can end the session. Okay, so we are going to so I am going to end the session. Okay, so next time we can start with the next set of instructions.